Second and third law of thermodynamics. So second law of thermodynamics introduces a new concept, that is entropy. And entropy is a thermodynamic function that describes the randomness and disorder of molecules based on the number of different arrangements available to them in a given system or reaction. Entropy is represented by the letter S, and entropy could be equal to, or change in entropy of a system is equal to Q reversible by T. So here del S is the change in entropy, Q reversible is the reverse of the heat, and T is the Kelvin temperature. So when we say is the reverse of heat and T is Kelvin temperature, that means we get the SI unit of entropy to be joules per Kelvin. And entropy is actually an extensive property of a thermodynamic system. Now that we are aware of entropy, we should understand what is second law of thermodynamics. The second law of thermodynamics is about the quality of energy. The second law of thermodynamics says that processes that involve the transfer or conversion of heat energy are irreversible. And second law of thermodynamics can also be conveyed in a different form as the state of entropy of the entire universe as an isolated system will always increase over time. So how do we relate second law of thermodynamics to that of entropy? So the second law of thermodynamics states that the total entropy of an isolated system can never decrease over time, and it remains constant only if all the processes are reversible. So the second law of thermodynamics could be represented in a form that del S is greater than 0. Here del S is the change in entropy of the universe, and that is considered to be greater than 0. So we could say that relation of your entropy and second law of thermodynamics is the total entropy of an isolated system will never decrease over time and it remains constant, but the condition should be that all the process should be reversible. And let us understand the third law of thermodynamics. So we learned entropy. Entropy could be the measure of system's thermal energy per unit temperature, and that is unavailable for doing any useful work. So now if we try to relate the third law and the entropy, it is considered that the entropy of a perfect crystal is 0 when the temperature of the crystal is equal to absolute 0. If the temperature of the crystal is absolute 0, that means the entropy of the crystal will also be 0. Or we could also simplify as the entropy of a system at absolute 0 will be a well-defined constant value. If the temperature of the system is absolute 0, then the entropy of the system will be a defined constant. It will be a constant value. So second and the third law of thermodynamics speaks about a concept, that is entropy, which is represented by the letter S.